Good day everyone, I am student 44, Geophysical, and I will be discussing geophysical methods. But before proceeding to our topic, let's have or define our learning objectives first. So by the end of this discussion, you are expected to 1. Define what are geological methods, 2. Determine various geological methods and their respective uses in different fields, 3. Understand the advantages and drawbacks of passive and active methods. Next, as you can see on your screens, we have a roadmap of our goal. So the very first one, we will have our brief introduction. Second, we will discuss about passive methods. Third, we will discuss about active methods. Fourth, we'll have a comparison of the pros and cons of both passive and active methods, and the fifth will be a conclusion. For a brief introduction, let us first define what is geophysics. So geophysics is a branch of the earth sciences which aims to understand the earth using the methods of physics. So how is geophysics related to geophysical methods? Well, geophysics uses specific sensors to detect one aspect of the Earth's physical field, and then uses this information to learn more about the subsurface. However, not all geophysical instruments are sufficient to resolve every portion of the Earth. Some methods are better in studying shallow portions of the Earth, while others can recover data even from the deepest parts of the Earth. Furthermore, these geophysical methods are divided or classified into two types, the passive and active methods. First, let's talk about passive geophysical methods. So what are passive geophysical methods? Passive geophysical methods use measurements of naturally occurring fields or properties of the Earth. Natural fields can come from a variety of sources, including those of the specific subject in the Earth being studied. To obtain a useful signal, one must eliminate the contribution from all other sources. The key word here is, or the key phrase here is, the naturally occurring fields or properties of the Earth. That the following are classified as passive geophysical methods. 1. Self-potential method. 2. Horizontal to vertical ratio method. 3. Magnetotellurics. And 4. Gravity method. So let's talk about this one by one. So first, let's have the self-potential method. So the self-potential method is a passive electrical geophysical method which was proposed by Robert Fox in 1830 after conducting self-potential experiments with mines in Cornwall, England. So how the self-potential method works? First, 2 electrodes are placed in the ground a couple meters apart, with one electric wire running from each electrode to the instrument. Then, 2. When the user takes a reading, the instrument reads the voltage difference between the 2 electrodes and stores the value in its memory. And the figure shown is an illustration of the process of the self-potential method. Next, after the initial reading is taken, the user then moves the electrodes one spacing forward and obtains another reading. The series of voltage reading shows if the ground is homogeneous, which means of the same value, or if an SP or self-potential anomaly is found. So what are the uses of self-potential method? Note that the uses are not limited to what I'm about to discuss alone. Well, first we have mineral prospecting or mineral exploration. The self-potential method was the first and is currently used in mineral exploration. SP method was utilized to find raw resources throughout the Industrial Revolution, making it very valuable. It is also used in oil firms. Self-potential is utilized in boreholes to locate porous zones containing oil. So what you can see on your screens, the figure shown below is an example of a borehole. Proceeding, we have the second classified passive geophysical method, the horizontal to vertical ratio method. In 1989, Yuta Nakamura revolutionized the microtremor analysis by presenting a new approach known as HV method, or this method is also called horizontal to vertical ratio or horizontal to vertical spectral ratio, or HVSR method. It is a method used to obtain information about shallow subsoil seismic parameters from single station readings made on the Earth's surface. So the keyword here is the word shallow subsoil. So it means that HVSR is mainly used for shallow subsoil exploration. So how does HVSR works? HVSR uses a single broadband 3-component seismometer to record ambient seismic noise, just like as what you can see on your screens right now. Moving forward, according to Nakamura's definition of HVSR is the ratio of the Fourier amplitude between the horizontal and vertical of motion recorded by a sensor on the free surface. HVSR can be expressed as follows. HVSR sub s is equal to H sub s over V sub s, where H sub s is the horizontal component of Fourier spectrum recording at surface, while the V sub s is the vertical component of Fourier spectrum recording at surface. What are the uses of HVSR? HVSR has a very wide range of applications, including site classification, site effect research, velocity structure inversion, and mineral prospecting or mineral exploration. Because of its inexpensive data collecting and processing costs, the method is extensively utilized to create a rapid microzonation map over broad areas, just like what you can see on your screens right now. That is an example of microzonation map of the Greater Bangkok. The third passive geophysical method is magnetotellurics. Dissected, magnetotellurics is a combination of the word magneto, which means magnetic, and tellurics, which means earth currents. Hence, magnetotellurics measures the electrical resistivity of the subsurface by utilizing natural time fluctuations in the Earth's magnetic and electric fields. So how does magnetotellurics work? First, empty data or magnetotellurics data is acquired through empty stations that consist of a setup. 2. After magnetotelluric data is collected, it is processed in a number of ways. Noise is eliminated from the data in part. So the picture that or the figure that you see on your screens right now is a typical magnetotellurics layout. Then third, comparing data from one station to data from another station that was captured at the same time is a part of the processing, and this process is called remote referencing. Fourth, empty interpreter takes the processed data and converts it to a real resistivity versus depth representation. To accomplish this, forward or inverse modeling can be used. How does forward modeling and inverse modeling differ? In forward modeling, the interpreter constructs a cross-section, calculates the empty response, and compares it to the acquired data, while in inverse modeling, the interpreter allows the computer to create a cross-section from the obtained data. So what are the uses of magnetotellurics? One is the reconnaissance mapping. MD was first used primarily for reconnaissance mapping of basins and geothermal potential. 2 is petroleum exploration. Self-potential is utilized in boreholes to locate porous zones containing oil. And the figure shown in your screens right now is an empty interpretation of an anticline in the fault belt in Papua New Guinea. Now, let's proceed to the fourth passive geophysical method, the gravity method. So what is gravity method? Gravity method is a non-invasive, non-destructive, remote sensing technology that is reasonably inexpensive. A gravity meter, or sometimes known as gravimeter, is a device that measures changes in the Earth's gravitational field. So what are the uses of gravity method? First is the location and size. Gravity methods are used to determine the location and size of major source structures containing hydrocarbon accumulations, massive base metal deposits, iron ore, salt domes, and hydrogeological aquifers, either alone or in combination with other methods such as magnetotelluric. And the figure shown on your screens right now is an example of a salt dome. The gravity method has found numerous applications also in engineering, environmental and geothermal studies, including locating voids, faults, buried stream valleys, water table levels, and geothermal heat sources. Last but definitely not the least, the Neves Corvo. The finding of deep-seated Neves Corvo large multi-metal sulfide ore bodies is considered as the most outstanding application of a gravity survey. First, they found no visible signature on the surface, and first few target drillings were unsuccessful. But after a year and a half, exploration drilling was restarted because to convincing bore anomalies. And there they found out about the large multi-metal sulfide ore bodies. Now, let's proceed to our third topic, the active geophysical methods. So what are active geophysical methods? While passive geophysical methods entail measurements of naturally occurring fields or properties of the Earth, active geophysical methods require an artificial signal to be generated. Active methods involve injecting a perturbation or signal into the Earth and measuring how the subsurface reacts to it. Now, we have three methods that are classified as active geophysical methods: the seismic refraction, seismic reflection, and ground-penetrating radar. And we will discuss all of these one by one. First, let's talk about seismic refraction. So what is seismic refraction? Seismic refraction is a surface geophysics approach that characterizes underlying geologic conditions by measuring the refraction of seismic waves on geologic layers and rock or soil units. The method is based on seismic waves' ability to refract or bend when traveling from one material to another with varying densities or elasticity. And the figure shown on your screens right now is an illustration of the process of seismic refraction method. How the seismic refraction works? First, a signal is transmitted to the subsurface from one source, and the refracted signal is received at a distance in refraction methods. Second, the returned signal contains information about the media it passes through. So what are the uses of seismic refraction methods? Seismic refraction is widely employed in a variety of fields, including engineering, environmental, groundwater, hydrocarbon, and industrial mineral exploration. In engineering, sledgehammering the earth with a hammer is sometimes used as an energy source for shallow penetration engineering research, and the figure shown on your screens is how engineers or surveyors use sledgehammer. And engineers are particularly interested in S-wave velocity measurements because building stability is dependent on the shear strength of the foundation rock or soil. Seismic waves can be used for a variety of other things. They are used to detect flaws that could disturb a coil or seam, or fractures that could allow water into a tunnel, for example. The figures shown are the equipments used in seismic refraction method. Preceding, we have the second active geophysical method, the seismic reflection. So what is seismic reflection? Seismic reflection is a geophysical exploration technology that offers information about the seafloor's subsurface structure. Hydrophones record the reflected energy waves, and the data is processed to create a visual picture of the seafloor subsurface. So what are the uses of seismic reflection methods? For sediments, this method has been employed to map thickness of sediments. Seismic reflection data, in addition to thickness, can often show sediment type and sedimentation processes. It is also typically used in oil and gas exploration, geological mapping studies, mineral exploration, and civil engineering site investigations. In land, seismic reflection is extensively employed on land to map a variety of deep features and is generally applicable to depths greater than 80 to 100 feet. In marine applications, this technique is also ideally adapted to marine applications such as lakes, rivers, and oceans, where the water's inability to transmit shear waves allows for the collection of high-quality reflection data even at very shallow depths that would be difficult or impossible on land. Here we have the comparison, side-by-side comparison of the seismic reflection and seismic refraction. As you can see on your screens, we could say that the seismic reflection method is applicable for not shallow areas, or for, we could say that it is used for the exploration or study in deep parts of the earth or in oceans. Lastly, we have the ground penetrating radar method. Ground penetrating radar method, or GPR, is a geophysical locating technique that uses radio waves to record images beneath the ground surface in a non-invasive manner. GPR works by sending a pulse into that ground and recording the echoes that come back from subsurface objects. And the figure shown is an illustration of how GPR works. Now, let's proceed to the application or uses of ground penetrating radar method. In locating objects, ground penetrating radar signals can be used to locate a variety of objects. When there is a significant difference in the electromagnetic properties of the target and the surrounding material, this subsurface technique is most effective. Next, we have railway engineering. It is used to measure track structure, condition, and evaluate the thickness of pavement layers. In civil engineering, it is used for multiple applications, including estimating structural integrity. Next, we also have forensics and security. It is used to locate evidence behind walls or under floors and finding hidden tunnels or compartments. It is also used in archaeology and heritage to locate building remains and archaeological targets before excavation and more. We are now in the fourth phase of our discussion, we will be discussing the pros and cons of passive and active geophysical methods. Now, it is important to know the pros and cons of passive and active methods because it will help the surveyor to decide better on what method to be used depending on his or her goal, the budget, and other factors. Now, first, let's have the pros and cons of passive methods. For the pros, we have surveyor need only to record a naturally occurring field, so it's a lot easier. However, on the con side, the surveyor has less control of noise because the source of the signal is out of hands of the surveyor. But On the pros side, field operations are generally very time efficient. However, these results in terms of anomalous geological contributions, which is difficult or impossible identification of the source. Let's tackle about the pros and cons of active methods. For the pros side, the surveyor has the better control of noise sources through control of injected signal, and since the surveyor has the ability to eliminate those noise in the process. And the con side, complex field equipment, both sources and receivers must be supplied. On the pro side, active experiments usually provide better depth control over source of anomalous signal. However, field operations and logistics are generally more complex and it is time consuming, and other than that, it is more expensive than passive experiments. And now to wrap things up, in sum, geophysical methods are classified into two types: passive methods and active methods. Self-potential, horizontal to vertical ratio, magnetotellurics, and gravity method belong to passive geophysical methods, while active methods include seismic refraction, seismic reflection, and ground-penetrating radar or GPR method. Each method differs from one another and each has their own pros and cons. Some methods are better in studying shallow portions of the Earth, while others can pick up data even from the deepest parts of the Earth. Furthermore, it is worth noting that both passive and active methods have their own pros and cons. Hence, the selection of the method or methods to be used in a project or study depends on its goals. Undeniably, geophysical methods have a wide range of application, from geologic mapping, climate evaluation and monitoring, slope stability and measurement, and other mineral environmental applications, to engineering applications such as bedrock evaluation, detecting buried infrastructures, geotechnical site characterization, and so on and so forth. Emphatically, the development of geophysical methods has made the humanity a step closer to uncovering the enigmas of the Earth. That is all for my report. I hope you learned something from me. Thank you so much for watching. Keep safe and keep sane.